Good day, viewers at home. Welcome to Home Learning. Today, you are with Mr. Dlamini, and we shall be going through the Form 5 Mathematics. It's better to learn mathematics by doing the problems. So therefore, learners at home, you should make sure that as we go through the questions I have today, you really do the problems. Should have your calculator, your pen and writing paper. As we go through, make sure you really do the problems. Without wasting our time, let's have a look at the first question for today. So here is the first question. It's a question on algebra. Marcus buys 2 bottles of water and 3 bottles of lemonade. The total cost is $3.6. The cost of 1 bottle of lemonade is 0.25, more than the cost of 1 bottle of water. Find the cost of 1 bottle of water. Okay, looking at this question here, you have to form 2 simultaneous equations and then try to determine that cost of 1 bottle of water. So to start off, you can say define 2 variables, that is your x, and define your y there. So in this case, we can let x be, say, the cost of 1 bottle of water. And then y, you can let y be, say, the cost of 1 bottle of lemonade. So let's have a look at our solution. Now, so you let x equal to cost of 1 bottle of, let's say, water. And then let y, let's say it's the cost of 1 bottle of lemonade. Then what will be the equation in terms of x and y for the total cost of that 2 bottles of water and 3 bottles of lemonade? So you can think of, because you given the total cost that it's $3.60 there. Then what will be the cost of 2 bottles of water and 3 bottles of lemonade in terms of y there? You should be able to get that cost by writing the expression 2 multiplied by the cost of 1 Berkeley of water, which is X, plus the cost of 3 Berkeleys of lemonade. So each Berkeley cost Y. So you'll have 3Y there. So that's the expression there which represents the total cost in terms of X and Y there. But then already you're given that total cost is equivalent to 3.6. So this should be equal to 3.6. So that will be your first equation. Then, looking at the second statement there, it's the cost of 1 Berkeley of lemonade is 0.25 more than the cost of 1 Berkeley of water. So you can write that statement in terms of X and Y. So what will be the expression or your equation there in terms of X and Y, which is represented by that statement there. So the statement is the cost of 1 Berkeley of lemonade is 0.25 more than the cost of 1 Berkeley of water there. So here you are saying the Y there. So this Y is actually the cost of lemonade. So it will be equivalent to 0.25 plus X there, which is the cost of 1 Berkeley of water there. So given the cost of 1 Berkeley of water, then you have to add more money, which is 0.25, to get that cost of 1 Berkeley of lemonade. So that's the relationship, basically. So you have your equation 2 there. Right. Then, looking at these 2 equations, you can then solve them simultaneously so that you are able to get, or you are able to answer this problem here. So which method are we going to use for solving these 2 simultaneous equations? So you have the elimination method, you have the substitution method. So which method is actually the best in solving these 2 equations? So you can think of the method looking at the equations. So that Y there in the second equation is the subject. So you can easily substitute Y by 0.25 plus X. So if we're doing the substitution here, so this Y here, we can substitute it by 0.25 plus X. So therefore, if we do that substitution, we'll get 2X plus 3 times 0.25 plus X equal to 3.6. So that's what we get there. Then removing the brackets and collecting some like terms, you can work it out there. This will result to an equation 2x plus, then you say 3 times 0.25, then you'll get 0.75 plus, then you say 3 times x there, so you'll get 3x. That's equal to 3.6. Right. So looking at this expression here, so you can see like terms, that is 2x and 3x there. Collecting those two, so we'll say 2x plus that 3x there, so you'll get your 5x plus 0.75 is equal to 3.6. Then, solving for x there, you subtract 0.75 both sides. So you'll get your 3x equal to, so we're subtracting this 0.75 there. So you're subtracting this 0.75. So what's 3.6 minus 0.75? Can work out that. So that will be 2.85. 2.85. Again here, it's like we have 3x instead of 5x. So the equation, it's 5x equal to 2.85 there. 2.85. Then dividing by your 5 there, so you'll get the value of x. So this value of x, if you punch your calculator there, 2.85 divided by 5, you'll be able to get 0.57. Right, so that's the value of x. Again, the x here represents the cost of 1 Berkeley of water. So therefore, you can write your answer there. It's 0.57 dollars. All right. Then we can have a look at that. That is our part 2 of the same questions. So we're still dealing with algebra here. So if you look at this question, that is a B. Now, looking at this question B, we are given 2 rectangles. The diagram shows 2 rectangles. The first rectangle measures x centimeters by y centimeters and has an area of 5 square centimeters. Looking at the second rectangle there, it measures y centimeter, which is the breadth, and x plus 2 centimeter, which is its length. The area there, it's 6 square centimeters. Now, when y plus y is equal to 1, show that x squared minus 9x minus 10 is equal to 0. So here, it's like the sum of the breadths or the widths there. So according to that statement there, y plus y. So small letter y plus capital letter y. So the sum of the breadths of the two rectangles, you should get 1 there. Now, looking at this, so it's possible to express that breadth of the first rectangle in terms of x, which is its length. So you can express the breadth, that is the length, yes, the breadth there, y centimeters, in terms of x, which is the length, using that area there. So how can you express that breadth y in terms of x? You should be able to use the area or the formula for the area of a rectangle. So here, the area A for rectangle 1 there, so it will be half, that is length times breadth. So that's the area there. Then your breadth, in terms of the length and the area, your B, that is dividing by L there. So your breadth should be equal to the area divided by the length. So in this case, you can write that breadth there, y, in terms of x there. So your breadth y will be the area 5 divided by the length x there. So that's the breadth of rectangle y. That is rectangle 1 in terms of x there. Similarly, you can look at the second rectangle there. So what will be the expression for capital letter Y? Expressing capital letter Y in terms of x there. So what will be that expression of that breadth of the second rectangle in terms of x? Now, looking at the rectangle, you should be able to find that y there, it will be the area 6 over the length x plus 2. So now we have the two, or we have expressed the two widths in terms of x. But then, referring to that statement, y plus y is equal to 1. So we can substitute y, that is small letter y, by 5 over x. And we can substitute capital letter Y by that 6 over x plus 2. Right, doing that here, it's y plus y, it's 1. So therefore, 5 over x plus 6 over x plus 2, that's equal to 1. Now, then we have to show that this equation reduces to that x squared minus 9x minus 10 equal to 0. So how can you reduce this fractional equation to get that quadratic equation there? Reducing this, you should be able to multiply by the LCM of the denominators. In this case, it's x and x plus 2. So your LCM there of x and x plus 2, it will be the product, that is x times x plus 2. So therefore, at this side, you can multiply this by x into x plus 2, which is the LCM of those two denominators there. Right. Multiplying this side, so each term, so even here, you multiply this by x times x plus 2, right? Then the last term is that term, you multiply it by x times x plus 2. Then you can cancel out that x there, cancels with that x, you remain with 5 into x plus 2 plus, cancelling there, should be able to find that you remain with 6x equal to this side. You have 1 times x, which is x, into x plus 2. Right. Looking at our equation, can reduce it further by removing brackets and collecting like terms. Now, 5 times x, so you get 5x plus 5 times 2, that's 10, plus that term there, 6x, that's equal to x times x, which is x squared, right? Then x times 2, again, that will be 2x. Now, collecting these like terms, that is 5x plus 6x, you'll get your 11x plus 10, which is that 10 here. Then that's equal to x squared plus 2x. Looking at this, one side must be 0, preferably that side which is our left-hand side. Now, so you take these terms on the left-hand side to the right-hand side. So you'll subtract the 11x both sides. Here, subtract the 11x, so remain with 10. equal to x squared, then 2x minus 11x. That will be minus 9x. Then to remain with 0 here, we subtract 10. Subtract 10. Then our equation will be x squared minus 9x minus 10 equal to 0. So we have shown that reducing this fractional equation, we get that required equation there. Okay. Now, if we look at part 3 or part 2 of the question here, it's factorize. So is that question there? Factorize x squared minus 9x plus minus 10. So I've given a quadratic expression, we have to factorize. Now, how do we factorize this? If you remember very well, a quadratic expression will have those 3 terms always. So to factorize this quadratic expression with 3 terms, you can look at the constant there. That constant term is minus 10. So look for the factors of negative 10. But when you add, so they have a sum of negative 9. Which are those factors? Multiplying these two, you should get the negative 10. So that's their product. But doing the addition, or adding, or finding the sum there, it should be negative 9. Then you should be able to get the 2 factors here, which is positive, or positive, let's say, or so it will be positive 10. So if you say positive 10 and minus 1, so you multiply there, it's negative 10. But if you add, you'll get positive 9. But then looking at our case here, when doing the addition, we should get negative 9. So you should see that your 10 should be negative and your 1 should be a positive there. So that multiplying, you get the negative 9, adding, so multiplying, you should get negative 10, and then the sum there, negative 9, right? Then once you have these 2 factors, if you are factorizing that quadratic expression with 3 terms, then we can have that double bracket. So multiplying the first term there and the first term in the second bracket, you should get your x squared. So you'll have x there. Then writing the 2 factors there, you should realize that you'll have minus 10 and here positive 1. So that's your answer there. And simply write x minus 10 multiplied by x plus 1. Yes. Then calculate the perimeter of the first rectangle. Let's have a look at our first rectangle there. So this is our first rectangle. We want to get the perimeter around that rectangle there. Then how can we get the perimeter? Then we need to know the value of x there. So we have to get the value of x. If you remember very well, we have shown that x squared minus 9x minus 10 is equal to 0. Then we can work out that value of x that is solving this quadratic equation. We have already factorized this expression. So this is x. It's x. So we've done it here. So it's x minus 10, x plus 1. So we have x minus 10, x plus 1. So that's equal to 0. Then we can look for the two roots. So here it's a product which is equal to 0. So therefore, either x minus 10 is equal to 0, or the other factor, which is x plus 1 is equal to 0. Right. Solving for x in each equation, you should be able to get here, adding the 10 on both sides, you get x is equal to 10, or here, subtracting 1, both sides, should be able to get x negative 1. So those are the two roots. But looking at the two roots, x can be 10 or x can be negative 1. So to get the perimeter, you should be able to choose the appropriate root there. Do we use the 10 for x, or do we use the negative 1 for x? So because this is a real problem, you expect that the length of a rectangle should always be positive. So in this case, we can use our 10 for the x there. Then, how do we get the perimeter of a rectangle? So the perimeter of a rectangle, P is equal to 2 times L plus B. So that's how we get the perimeter of a rectangle. So in this case, we know the length, which is 10. But then, what's the breadth? Y there? If you remember very well, we said the breadth is equal to the area over the length. So in this case, we are saying this L is 10. So what will be the breadth? We know the area there is 5 square centimeters. Then what will be the breadth? Working out the breadth here, should be able to get B equal to 5, which is the area there, over 10, which is 0.5. So that will be the breadth. Then coming back to our perimeter there, so it's 2 times your length, which is 10, plus your breadth, which is 0.5, removing those brackets. So you'll get, in fact, you can first add there to get the 10.5. So we'll have 2 times 10.5, which is equal to 21. So that's our perimeter there. So our perimeter, we're saying it's 21 for that rectangle. That is the smaller rectangle there. Right. Now, can have a look at the next question here, still on algebra. So it's just another question similar to the one we've just worked out. Here is the question, right? So we are given this triangle. Looking at the question, the diagram shows a right-angled triangle with sides, length 5 centimeters, x plus 3 centimeters, and 2x plus 3 centimeters. So just given those 2 expressions for the hypotenuse and that side there, and then 5. Show that 3x squared plus 6x minus 25 is equal to 0. So using this right-angled triangle, you can show that, in fact, we can form an equation and show that it reduces to the given equation here. Then how can we form this equation? We have to know the properties of the right-angled triangle. So a right-angled triangle will always satisfy the rule of Pythagoras. So the rule of Pythagoras is that the square of the longer side is always equal to the sum of the squares of the 2 shorter sides in that triangle. So if we name our sides, say here, this is your A, this side, let's say it's B, this side, which is the longer side, hypotenuse, we call it C. Then you can write the rule of Pythagoras. So it's C squared is equal to A squared plus B squared. So that's the rule of Pythagoras there. But in this case, we're given the length of A and C in terms of x. So therefore, we can then substitute this, C squared, so you'll see it's the length of that side. So you should be able to see that Your c is 2x plus 3. Then you square the c, so you square that expression. So that will be equal to your a squared. So your a squared will be x plus 3 squared plus your p squared, which is that 5 squared. Now, removing these brackets, so your 2x plus 3 squared, you expand it. So it's 2x plus 3 times itself, which is 2x plus 3, equal, expanding that, you get x plus 3 multiplied by x plus 3, working out 5 squared, should be able to get 25. Removing the brackets here, multiplying the first with that first term there, get your 4x squared. So 2x times 2x is 4x squared. Then that 2x, you multiply it with 3 there. So you'll get positive 6x. Down here, that 3 times 2x is positive 6x. Then the 3 multiply with that 3 is plus 9, equal to, doing the same thing there, expanding x plus 3 times x plus 3, should be able to get x squared plus 3x plus 3x plus 3 times 3 is 9 plus that 25. Then you can collect like terms. Coming to the left-hand side, it's 4x squared plus 6x plus 6x. So that will be 12x plus 9 equal, collecting like terms this side, you get x squared plus 6x plus, then your 25 plus 9, that will be 34, right? Then taking these terms across, because in our equation we have 0 one side, so you can take these terms across, meaning that you subtract the x squared both sides, and that 6x, we have to subtract it both sides, and that 34 has to cross to the other side. So we'll get minus 34 there. So this side, you'll get 0 there, because you'll subtract the x squared. So x squared minus x squared, that will be 0. Subtract the 6x. So this side, you subtract x squared, subtract 6x, and subtract the 34. So this will be 0. And then this side is 4x squared minus x squared. Should be able to get your 3x x squared plus, then you say 12x minus 6x, you get plus 6x. Nine minus 34, that's minus 25. So you get that we have shown that simplifying, you get 3x squared plus 6x minus 25. Then you can have a look at that question there. It reads, solve the equation 3x squared plus 6x minus 25 equal to 0. Show all your working. Give your answer correct to 2 decimal places. Give your answer correct to 2 decimal places and show all your working. So the fact that you are given accuracy of your answer there, it means your answer will not be exact. So your answer might be a full calculator display, but then you have to give it correct to 2 decimal places. There are various methods of solving quadratic equations. We have the factorization method. We can use the quadratic formula. You can use the method of completing the square. All those methods are used to solve quadratic equations. But you should be able to choose a method that is suitable for the given problem. So in this case, because your answer won't be exact, you should be able to see that you cannot use factorization to find the roots of this quadratic equation. So we have 2 options. You can either use your quadratic formula, or you can use the method of completing the square. But it's easier to use the quadratic formula. So we have to recall the quadratic formula. So the formula for solving a quadratic equation, if you remember very well, it's x equal to minus b plus minus a square root b square minus 4ac, that's over 2a. So that's the formula, which you call it the quadratic formula. Then the 3 coefficients, that is a, b, and c, should be able to get those 3 from your equation. So your general expression for a quadratic, it's a x squared plus bx plus c. So you have ax squared plus bx plus c. So your a is the coefficient of x squared, your b is the coefficient of x, and your c there is that constant term. So in this case, looking at our equation, you can see that what's the coefficient of x squared? So it's 3. So your a is 3. Your b is that coefficient of x, which is 6. Your c is equal to that constant term, which is negative 25. So that's the constant term. Then substituting that into that quadratic formula. So looking at the formula, should be able to see that your denominator is 2a and your numerator is negative b plus or minus the square root of b squared minus 4ac. So we can substitute here. So your x will be negative times our b there, which is 6 plus minus a square root, then your b squared. So here we have 6 squared. You can put that in brackets. That's your 6 squared, which is b squared, minus, again, the 4ac, can write that in brackets. So it's 4 times your a, 3, times your c, which is minus 25. So this will be divided by 2 times your a, which is 3, right? Then working out the value under the square root. So you can use your calculator to work out 6 squared minus 4 times 3 times negative 25. You can calculate that. So here we'll get negative 6 plus minus a square root. So if you work out the value under that square root, you should be able to get, 336 there. Then you divide this by 2 times 3, that's 6. Then your 2 roots, so use the positive and the negative there. So your first root is x is equal to negative 6 plus a square root 336 over 6. Working out that, should be careful on how to punch the calculator. Should be able to put this in brackets to ensure that you get the correct result using your calculator. So your numerator, that is negative 6 plus a square root of 336, that numerator, you can put it in brackets before you can divide that by 6. Doing that with your calculator, so you get a full calculator display of the answer. So this will be x equal to
2.050500463. But then you're supposed to give the answer correct to 2 decimal places, rounding off. So in this case, giving this correct to 2 decimal places, so you can look at the third figure after the decimal point. If it's 5 or more, then you have to add 1 there. So in this case, so this rounds to 2.06. So that's your answer there. Your first root is 2.06. Similarly, using that, you can get your second root. So your second root is x equal to -6. It's -6. Now we'll use the negative sign then. So it's minus a square root 336 so it's 336 over 6. Once again, you'll get a full calculator display, but rounding it off to 2 decimal places, you should be able to get x equal to -4.06. So your answer is -4.06 there. So that's the solution there for this quadratic equation. As I've said, you can be able to use the quadratic formula to get this solution, but there is this method of completing the square. Calculate the area of the triangle. So the same triangle here, so area is half base times height. It's x plus 3, and that height is 5. So it will be half multiplied by x plus 3 multiplied by 5. But then your x there, use the positive root, which is x is 4 point or 2.06. So it will be half times 2.06 plus 3 times 5. Working out this, you should be able to get 12.65 square centimeters as your area there. Until we meet next time and enjoy some more mathematics, have a good day.